Hello, and welcome to today's AWS Partner Webinar Series, where our topic today will cover how to optimize your cloud applications and infrastructure performance on Amazon Web Services. My name is Sherry Sullivan. I'm your host and moderator today, and I'm with the partner marketing team here in Seattle. Just a couple of housekeeping items before we do get started. I'd like to remind folks that we are recording today's webinar, and while your lines are muted, we do encourage you to submit any questions anytime during the presentation. You'll find a Q&A pane in your browser, and feel free to submit your questions. We'll take some time at the close of today's webinar to answer questions. And in addition, I'd like to let you know that we'll make this presentation available on our AWS, SlideShare, and YouTube channels as well. So we have a great presentation today with cloud expertise that spans from AWS side. We have Miles Ward, who is a manager with Solution Architect, and we have our technology partner, Boundary. We have Dustin Lawyer, who is a director of technical services, and we have a customer today, Adam D'Amico, who's the director of technical operations at Okta. So without further delay, I'd like to welcome our speakers and turn it over to you, Miles, to get started.
Thanks, Sherry. I appreciate that. My name is Miles Ward, and what I'm hoping to cover today as a useful intro to Boundary's demonstration of their exciting technology is how AWS has approached this market space and really what we're providing as a foundation to build your applications and infrastructure services up here in the cloud. So where we started with this process, the place that we saw as a challenge for every business, not just technology businesses, not just businesses that were building web applications, but every company that used computers found that infrastructure is a very costly and complex enterprise. You have all of these sort of capital expenses, very significant impediments to growth, and generally a very, very large fraction of the real effort to build these kinds of things is undifferentiated heavy lifting. It's the same work for every different company to turn on the computers and rack them and stack them and make sure that they're all assembled in the right way. And so we thought there was a better alternative to that. The public cloud proposition and the Amazon Web Services proposition is that there's a very different way to approach infrastructure. So if we take the responsibility of holding the physical infrastructure and we build a service for you out of that, it eliminates your upfront investment. You don't have to expend a bunch of capital to experiment or to build scaling and changing production infrastructure. As a result of that, you don't have nearly as much risk when building systems. So much lower total cost to deliver even full-time running production applications because you don't have the same kind of lock-in to the physical design of your infrastructure. That drove us to the consumption model that we've built, this utility model for pricing where you pay only for what you use, and you pay only when you use it. So, if you use storage with our S3 service, you pay, for that storage only based on the actual consumption. So that we knew that people needed all of that flexibility around the cost of things, but they also need an incredible degree of control. That's one of the places where I'm interested in today's webinar is to look at the extra controls that tools like Boundary can provide in an infrastructure like this. Our environment's self-service, so you don't have to ask for any help from us. A complete RESTful web services API and easy-to-use tools for provisioning and deploying infrastructure that make it so that it's very, very easy to scale up and down according to actual load. Don't certainly have to trust me that this is the way to do it or that it's the best and most efficient way to deploy infrastructure. Many of the participants in the analyst community have come to the same conclusion. We work together with many of them, and we're not just in the upper right, we're way in the upper right with the guys at Gartner on the subject of who's both the most visionary and the clearest executors in the context of building a cloud infrastructure as a service. There are a lot of different reasons for that. It's not just that we built on top of the expertise at Amazon.com, but we've also really focused on building the most open, the most flexible, the most compatible infrastructure that's available anywhere. So, we're fine if you want to run enterprise Linux, open source, free Linux. You want to run Windows as a billion different formats, that's fine. All of the different programming languages that you can run and develop applications in. We have SDKs in PHP and Ruby and Bodo and Python and command line interfaces, so that you can build in whatever is most compatible with your infrastructure. Or if you're not building new software and you're just running software that you've purchased, we have certified relationships with the major application providers to make it as easy as possible and quick as possible to get value back out of your investment in technical infrastructure. And what we've found as a result of that is that there are a very wide range of use cases. Our customers are running their entire businesses built on top of us, not just a great place to back up your data, or a simple way to deploy a website, or a straightforward place for storing images for your applications. We're talking full line of business enterprise applications, business critical components. There are hundreds of thousands of businesses literally in 190 countries. I didn't even know there were 190 countries across the globe that are using our infrastructure on a daily basis. And I think the focus of this webinar is to look at a set of tools that, when this isn't an experiment, when it's not a test, when you're using infrastructure to build the foundation of your businesses, you need incredible tools to be able to help you ascertain what exactly is going on inside that system. We have services for monitoring and for evaluation, but they provide the basic looks at the performance of your individual resources from us, the EC2 instances and other services that you consume. I think that's one of the places where this is going to be an exciting review from Boundary, is to look at how you can establish an understanding of the interconnections between those services. There are lots of companies that are in the middle of trying to understand what systems they want to deploy, how they want to deploy them. A big ingredient in that decision-making process is looking at the geographical diversity of our infrastructure. We're growing very, very rapidly. So today you can build services not just here in the United States, but deploy exactly the same infrastructure footprint, running on exactly the same automation, managed using the same tools, under the same contracts with the same providers, in Europe, in Tokyo, in Sao Paulo, in Singapore, all over the globe. And this is a pretty gratifying chart for us to look at, because we've been growing very quickly. So over the course of even just the last several months, you've seen us continue to introduce new infrastructure footprint, and we'll continue to grow that footprint over time. That inside of that distributed fleet of infrastructure resources, we've built a full stack of support tools and application enablement structures to make it so that any different kind of business, building any different kind of application, or running any application that you've purchased, can use resources from AWS to do so efficiently, to do so scalably, elastically, and very, very securely. So each of these different services work together. There are different patterns, and certainly encourage folks to look at the architecture section of the AWS website for more details about patterns for installations. But across all of those different designs, it's always very, very critical in any of the different systems that you assemble to have a clear understanding of how everything's working, to get clear information about performance and about application stability and those other pieces. So I'm excited to hear the next portion, I'm sure you are too, about the details from Boundary. With that, I'm going to hand it over to Dustin. Thanks so much.
Great. Thanks, Miles. All right. So once again, my name is Dustin Lawler. I'm responsible for tech services here at Boundary. I'm just going to be kicking this off first by going through a couple of slides. This is going to be very, very light on slides, and I'm going to immediately dive into real products so everybody can get a sense of how Boundary works, what it looks like, and how easy it is just to get it set up and running. So with that, first come over to here. And so with new challenges for ops, environments are larger and more diverse than ever and will only continue to add additional complexity over time. Today's systems that ops engineers are tasked with architecting and maintaining are no longer just print and mail servers for internal traffic. Instead, modern systems generally consist of a myriad of diverse applications such as Redis, Zookeeper, Hadoop, various NoSQL platforms like Cassandra, and then languages like Erlang and Scala being introduced. In addition to the applications and languages changing, many of them are finding completely new infrastructures to call home. Amazon Web Services. Now, with AWS provides an ideal and diverse infrastructure for these modern apps, as it's an easy way for companies, new and established, to experiment and later productize their services. In addition, AWS also provides the convenience and flexibility of auto-scaling, zones, regions, and more. However, these capabilities become a moving target for the ops teams to measure and maintain, all in an infrastructure they no longer own. Now, tools that lend themselves to helping with orchestration and maintenance behind these modern applications and infrastructures come with their own unique challenges. So understanding the impact brought on by tools like Chef, Puppet, Jenkins, and the general impact brought on by change in the environment becomes impossible at scale and can lead to disastrous implications. Now, this next slide here, there we are. All right, so with this next slide here, what we're looking at is Boundary is a solution which is built entirely from the ground up for ops teams with focus on providing insight into distributed systems regardless of where they live. So it can be in cloud, it can be virtual, physical, or a hybrid environment with some or all of the above. Boundary provides this insight by processing a tremendous amount of flow data at real time and immediately presenting it to our customers while it's in flight, allowing users to immediately understand what's happening while it's happening as opposed to sampling or polling after the fact. To help aid in understanding what's happening on screen, the Boundary dashboard may be enriched with external events from tools such as Splunk, AppDynamics, Puppet, and many more so users know where to react. It's OODA in practice. So observe, orient, decide, and act. Now, some of the unique characteristics that go into making a Boundary. It's, with Boundary, it delivers its monitoring without the use of hooks or invasive instrumentation, making it easy to be up and monitoring your apps and your infrastructure within seconds. Because the Boundary agent leverages network flows as opposed to instrumentation, we're immediately capable of understanding communication across your app tiers with little to no configuration. Once installed, the Boundary agent immediately streams data to our SaaS solution, providing instant gratification. We process and present the data at real time through our big data analytics system. Boundary is 100% SaaS, which means the only thing our customers need to install within their infrastructure is the lightweight agent. So there's no need to own or maintain any additional infrastructure, meaning it's immediate time to value. And then with this one here, these slides pretty much speak for themselves. It's the points on this slide, the underlying theme with what you're seeing here is cost savings. So each of these points here, we can see Mega, High, Okta, and Simple. So with each of these slides, or rather with each of these points, you can see Boundary helps the users gain new insight into their infrastructure, allowing them to make more informed decisions when it comes time to adding new components. So this isn't going to come to a surprise to anyone, but throwing more hardware and subsequently more cash at problems generally isn't the right solution. So with Boundary, you're able to get this new type of insight, which shows you, exactly where it is traffic's going to, where it is traffic's coming from, and so on. All right, now with that, what I'm going to do is attempt to share out my screen so that I can present our product. So let me just go ahead and kick this off. Okay, perfect. Now, From here, real fast before I go into the demo, at the end of this, if you like what you see, and you absolutely all will, by all means, please go to boundary.com/signup/AWS, and you can get registered for a free account. Again, the product, the setup, it's all frictionless. So you can sign up here, no credit card required or anything else, and you can get going with a free account. All right, so just to jump in from here, I'm just going to start off by looking at the AppViz view. So again, with Boundary, remember, 100% SaaS, so none of this infrastructure, none of actually getting the product stood up needs to be set up on your side. So the only thing that you need to do is first install the Boundary agents. Once those agents have been set up, you're going to automatically start to feed information into our UI. So this default view that we're looking at, this is called AppViz, and just as the name implies, it gives you a visual representation of each of your application tiers, or each of your groups or silos of nodes. So with Boundary, one of the things that we do is, we kind of look at servers as being a necessary evil. So, in this particular view, what we're looking at here is the entirety of the infrastructure that goes into making up app.boundary.com. So these are real systems for real applications, and going into making up this view are 120 individual servers. Now, again, servers are a necessary evil, so we don't put a tremendous amount of focus on what's happening with these instances individually. Instead, we're rolling those up into groups so that people can get a good understanding in terms of what's happening on a group-to-group perspective. So from here, if I want, I can go in and I can pull out my data store front end, or I can pull out my internal web servers. Or if I want, I can very quickly organize this view and I can say, okay, well, you know what? The only thing I really care about is my streaming tier. So I can go in and I can start to shift these around, and I can make these views start to make more sense to me. Now, again, with this view, what we're focused on is what's happening from a group-to-group perspective. To get to this type of view, to get to this high-level operational view, everything starts off with first installing a Boundary node. Now, these Boundary agents are lightweight, written in C. They can be installed on all the platforms that are currently supported by Amazon, along with a few others that are out there. Now, once those are installed, then one of the things that's taken place during the install process is we're actually checking to see if it's an EC2 instance. If it is, Boundary is then going in and we're pulling out the EC2 metadata information so that we're translating the EC2 tags into Boundary tags so that users can later take advantage of those, so you can start to build out those groups that you saw on screen. So again, you install the agent automatically pulls this off, and it automatically pumps it into Boundary. So the first hurdle is out of the way. As you start to get those nodes registered and as these tags start to come in, then you can take advantage of these tags by building out what we refer to as dynamic groups. So a dynamic group, just as the name implies, I can come over to here, and a dynamic group is just a way for you to set up elastic groups so that your nodes can automatically, or rather your node groups can automatically grow and shrink based off of your environment, which is extremely convenient for people that are taking advantage of auto-scaling. So just to show you, to get this going, if I want, I can come in and I can build one from scratch, and I can say, I need to monitor every one of my instances which is currently running on Ubuntu. So that's perfect. You can see by running that, I'm now looking at a total of 115 servers that I could potentially be monitoring. If I want, I can save this as is, I can call it a day, and I can start to look at what's happening within this group. However, if I want, I can keep I can keep refining this, and I can keep adding additional criteria. So I can say, okay, well, 115 servers, that's great, but what I really need to see is only those servers which, let's say that are running React. So I can reference my tag here, and I immediately jump down from all those servers that I had earlier to 9 instances. And then again, if I want, I can save this as is, or I can refine it even further, and I can say, however, the only boxes that I really care about are those that are running in 1E. So we can drop that in, and we can specify the site. So now we can see a total of 6 matching servers. And again, once I save this, it's going to become part of our processing tier, or rather our streaming tier, So every second we're going to check to see if any new nodes have been introduced or if any nodes have been removed from this particular group. So moving forward, this becomes a living group, so I no longer have to go in and have to worry about maintaining or updating this over time. So once these groups have been added, you can take these groups, you can save them, and you can re-reference them in a couple of areas. So the first area being that view that we were looking at before, which was in AppViz. Another area that we can go to is directly into the dashboard. So real fast, before I go there, I'm just going to transition back to AppViz and just call this out. So here we can see I can go in and I can pull out these particular groups that I care about. And you can see that when I select a group, it shows me those individual nodes that I just referenced. Now, with these groups, I can take these, I can start to rearrange them. I can save these so I can re-reference them. Now, I can take the view from here, so from this good high-level operational view, and I can start to get an understanding of the traffic that's moving from app tier to app tier. So a couple of things to call out from this view are, with these lines that you're seeing being drawn from view to view, these lines are all being automatically generated based off of the flow traffic that Boundary is collecting. So remember, Boundary, it's agent-based. Those agents look at all the traffic that's coming into or coming out of the NIC. So we're taking the flow data, we're assembling that into flow tables, and then we're streaming that off to the Boundary service. Once it hits the Boundary service, we're processing the data. We're able to pull out certain things such as source, destination, port protocol, which is allowing us to build out these views. So, with a topology view like this that you're looking at, this is being built regardless of the infrastructure. So, we don't care about the router, the switch information, because it's all happening from the perspective of the servers using the flow data we're capturing from the servers. Now, the other thing that we can do from here is, if I want, I can select any one of these lines, and I can get a sense of not only the volume of traffic that's moving from app tier to app tier, but you can see in this widget down here, I can actually see the particular flows that are moving from app tier to app tier. So, with CloudWatch, today CloudWatch is going to do a great job telling you if you're sending a lot of traffic or a little traffic. However, Boundary actually tells you what's inside that traffic. So it's not enough to necessarily know that you're sending, a lot of traffic or little traffic. Instead, what you really need to know is, okay, well, 80% of that traffic is HTTP traffic. The other chunk of traffic is, maybe it's some random SSH traffic, or maybe it's some MySQL traffic that shouldn't be leaving, or maybe something else. So that's really where Boundary is able to dig in and help you start to get that new insight. The other thing that we're looking at here is not only Boundary drawing these lines and figuring out the volume of traffic, but we're also able to determine application round trip time. So people can start to understand if connections between their app tiers are potentially moving things slower than they should be. So if you have any latency. All right, so take it from this view. And the next thing that I can drill into is the dashboard. All right, perfect. So going from that, again, that great high-level operational view. So going from there, you can then transition into the dashboard. And the dashboard is here to give you a sense of what's happening at real time. So this view is showing us at 1 second resolution all the traffic which is currently moving through my stream processing service. So this is the group that I jumped into from earlier, and we can see here's my 8 individual nodes, but again, we're not putting a lot of emphasis with what's happening on these servers individually. Instead, we're looking at all the traffic that's currently being processed across all these servers. Now, again, by default, Boundary is going in. We're looking at what's happening from 1 second resolution. With 1 second, we're maintaining the last 24 hours of 1 second data. From there, it gets rolled up to the last 60 days of 1 minute data, and then the last year of 1 hour data by default. Now, with any of these views, I can also come in, I can take these, and I can use these as a jump-off point so I can go down to any other point in time so I can see exactly what's happening. So again, I have the option of seeing what's happening at real time, or I can go back historically to see what's happened. Now, other options that we have from here, I can go in and I can, this is a multi-dimensional view, so instead of just looking at the volume of traffic that we're processing, I can start to drill into things like bits or packet retransmits, out-of-order packets, and application round-trip time. So each of these metrics help people start to get a better understanding of their applications, their network, and just in general, how things are communicating and what's being processed. You can also use these, so not just at this group level, but instead of seeing what's happening within a particular group of servers, I can move over to here and I can see how servers are actually, or how groups of servers are communicating to one another. So for example, for instance, I can come to here and I'll pull out the, let's go into the collector data store backend. So for this particular view, I'm now looking at how traffic's moving from 6 nodes over to my 12 nodes. Or better yet, let's come into here. All right, perfect. So now with this view, I'm looking at how my collector tier is currently interacting with my messaging tier. Again, in this particular instance, we're seeing what's happening with, from an app view to another app, to another group of app servers. However, I also have the option of going in and setting up these groups based off of locations. So I could be looking at things like, okay, well, show me how zone to zone things are currently communicating. Or, maybe you're in a hybrid environment and maybe you need to understand how your, legacy data center is currently communicating with your Amazon instances that are out there. So it doesn't just have to be with focus on what's happening within these application tiers. Instead, it can just be based off of arbitrary groups that you have defined as well. Now, in this view, again, we're looking at how traffic's being processed across these two groups. And then if I want, I can take this and I can pivot from top traffic types, and instead I can focus on my top nodes. So top nodes allows me to come in and get an understanding of how this particular traffic is actually moving across these application tiers. You can see from here I've slid down a little bit on screen so I can start to get a sense of where things have been at on average as far as all this traffic goes. So this is a really good way for me to come in and start to identify where I might have outliers. So maybe with these messaging servers, maybe with these Kafka boxes right now, maybe I expect there to be perfectly well-balanced traffic moving across all 4 of these servers. So I can use this to start to figure out, okay, well, obviously that's very clearly not the case. With mess 2 and 4, we're pretty much in line with one another, but with mess 1 and mess 3, we clearly have, some traffic where, mess 01 appears to be significantly more overloaded than mess 03. So again, that could be something right there that's worth looking at. Or instead of just looking at the volume that's being processed, I can go in and I can look at retransmits. So I can come into here. So again, I can start to get a sense of where we're retransmitting too much traffic, where maybe we just need to move the load around or shift around some of our app configs. And again, one of the things that I keep trying to, that I'll keep pushing on here throughout this presentation is the fact that this view, the only real thing that the end user has to get set up within Boundary is installing the nodes. Once those nodes are installed, you get the groups configured, and then everything else pretty much just populates itself with very, very little to no effort. So this particular view here, the only thing that I had to do was call out the specific groups that I wanted to work with here. Everything else just populates itself. So there is no need for any kind of hooks, no need for instrumentation. Because we're looking at all the traffic at 1 second, we're immediately able to flood these dashboards with all this information. So a lot of our customers, it's pretty much inevitable that if you drop Boundary in, because of the sheer volume of data that we're able to collect at the 1 second resolution, that people are immediately finding things. And again, finding things isn't just about, seeing that there's a lot or a little traffic or something else. It's figuring out where the traffic's going to or where the traffic's coming from. I don't just have to focus on, traffic type or nodes. I can also drill in and I can start to get a sense of top countries where we're currently receiving traffic, or top networks where we're currently sending or receiving traffic. So these are all views that will automatically populate the moment you drop the agent in. All right, so Some other things to call out here would be alerts. So, I spent a lot of time talking about how you can use Boundary to come in to observe what's happening within your environment, but that's obviously, not always enough. So some of the things that you can do in Boundary are you can set up notifications based off of thresholds that you see in here. So, for instance, if you suddenly have, too much traffic going to a particular country, or too much traffic going to particular applications, or maybe if you suddenly see, a massive drop in traffic between application tiers or with HTTP traffic, that could be something right there that's actionable. So you can set up notifications in Boundary based off of email alerts. We have integration with PagerDuty. You can use webhooks, so you can call those out. And then the other option is a feature that we have in the product, which is called an annotation. And an annotation is a really good way to add context with what you see on screen. So annotations, those can be set up either, again, configure alerts. I can go in and set those from there. Or if I just want to kick one off ad hoc, I hit Actions, Create Event, and I can say, example. I can give it a basic name here, and we can see that the moment that I click Save, it immediately posts that annotation onto the dashboard. So these, you can kind of look at these annotations as being like breadcrumbs. And these annotations don't only have to be posted, through the means that I just explained. In addition to those, we also have out-of-the-box integration with tools like Jenkins, like Chef, like Puppet, Capistrano. There's plugins for AppDynamic, for New Relic, for Splunk, so that then you can start to have either those change management or automation tools or some of those other monitoring tools immediately posting their events into Boundary. So that way you can start to figure out what the impact of certain events are. So, here with Boundary, Boundary's obviously doing, an incredible job processing and showing a lot of information all at once. However, going back to those slides before, you can use Boundary to observe what's happening and then figure out, okay, well, what's the actual impact that this event has had? Is this something that, where we've suddenly stopped processing user data, or have we suddenly stopped, posting messages for our customers? So this allows people to actually come in and figure out what the impact of specific events are. One of the other killer features in here is, instead of just seeing what's happening on screen or having to jog back to see where things have happened over time, we're also maintaining all those events within Boundary. So if you want, you can come in, you can re-reference previous events, and then from here, you can jump off from these events into the dashboard. Actually, one thing to call out real fast is, so we have all the options that I talked about before, but then we also have RSS integration within Boundary. So with Boundary, we'll subscribe to RSS feeds that are out there. So if you wanted to, you could take your AWS status RSS feeds. Boundary will then parse those, we'll check those, and then based off of any change with your RSS feeds, we automatically post those into the annotations view. So from here, these are legitimate messages that were posted the other day by Amazon. And if I want, I can go in and I can see, okay, well, did this actually have any impact or any effect on what was happening within Boundary at this point in time? And from here, you can see it immediately jumps back to this point, and I can see that, obviously, based off of this view here, there was no negative change or there was no impact based off of our traffic. All right. So just to recap, so earlier I focused on AppViz, so being able to visualize application topology, get an understanding of exactly how things are communicating to one another. And that view is automatically generated based off of those flows without any need to understand, router switch, no S&P information needing to be involved there. The next thing was going in, actually showing how groups and how those views were set up, and then from here jumping into the dashboard to show how you can visualize your traffic as it's coming in at real time. Now, one last thing to point out is, instead of just focusing on what's been happening at real time, you also have the option in Boundary of setting up automatic alert distribution. So you can come into here, you can configure your reports, and then Boundary will automatically start to generate these reports on a daily basis. So every 24 hours, you can receive an update showing exactly where your traffic's been. You can see, where traffic has experienced high levels of application round trip time or high packet retransmits. Another slick thing about these is you can go in and you can see what the change has been over time. So Boundary, we're also measuring the change from the last week that this was measured to today, so you can get a sense of where things have been, rising or falling. And that really, for the most part, those are a lot of the highlights worth showing you here in the product. We have a ton of use cases that we could go over. So if anyone's interested in a more detailed demo, or if anybody has, a lot of questions for us, by all means, feel more than free to reach out to Boundary. We can get a one-on-one demo set up for you. You, of course, have the option of coming back to here, and you can sign up for your own free Boundary account. So lots of ways that you can check out the product and get in touch with us. With that, I'm just going to stop my sharing. And there we go. And next up is Adam from Okta. Thanks.
There, Adam D'Amico here from Octa. Just really quickly about Octa and why we use Boundary. We're a multi-tenant SaaS application that is essentially enterprise identity as a service. We decided really early on to build the service on public cloud infrastructure, which I'm very glad of, actually, having been here for 3 years now, running exclusively in AWS. We've been an AWS customer long enough to have 5 availability zones in the US standard region that we can use, and we've deployed every component of our application across all 5 of these zones. And so what that amounts to is a lot of packets flying back and forth among tons of servers and quite a few different physical data centers. And the reason we we started using Boundary is really, and Dustin touched on this, standard monitoring tools, whether it's Nagios or Zabbix or Xenos or even CloudWatch, you really only get high-level Ethernet statistics. And in the public cloud, you don't have access to the network metal. If I were still running my own data centers like I was 4 years ago, then that'd be a different story. I'd have access to the routers and switches. I could export the flows. I can do all kinds of things with the network metal and the access that I'd have. But in public cloud, being completely abstracted away from that, we really immediately saw the need for another tool to give us a better view. And Boundary is that tool. It gives us an unprecedented flow-based view into what's happening with all of these hundreds of servers that we have. And being the central identity broker and domain controller for our customers, we naturally have some pretty strict requirements about uptime and performance. And this ends up translating into some very tight tolerances in terms of what we can handle in our inter-instance networking. And Boundary has been a really great tool to help us get some deeper performance insight into our EC2 networks. So beyond that, there's 2 use cases, ways we use Boundary that I wanted to talk about here. The first one that we run into from time to time is zone partitions. And what will happen is we'll get an alert that essentially warns us that some app servers, for example, in US East 1A, maybe have lost sight of their databases in US East 1B, 2 different availability zones in US East 1 region of AWS. And so when we receive that alert, and it naturally causes a problem because these app servers can't talk to their databases anymore, we can go take a look in Boundary, and I can see the real-time graph at 1-second resolution for the conversation that is described by traffic between these 2 zones. I've never been able to do this with any other tool before. And when we look at that, we can look here at this screenshot and observe a flat line between these 2 zones. And then that obviously tells us kind of what's going on. Take a screenshot, open an AWS support ticket. Hey guys, what's going on? Can you help us out? So that has been hugely, hugely helpful when we have any kind of network hiccup. And the scale at which AWS operates makes it very important for us to have this level of insight into the shared network resources. The next case I wanted to talk about here was what we call MQ split brain. So one of the components of our platform is a message queuing subsystem. If anyone on the phone has ever dealt with message queuing subsystems before, you probably understand that when you've got a partition in your queuing brokers, that can cause all kinds of havoc with your application. And so we've seen various conditions where we get to a state where the slave brokers in our network start behaving like master brokers. And this is a situation that we've dubbed split brain. And what's great about Boundary is that if we're not getting the insight into this condition from the logging that comes from the broker servers, which we don't, the network can tell us exactly what's going on. And we can see a situation like the screenshot you're seeing here, where there's sort of a background hum of, yes, I'm alive, I'm alive, I'm alive, by the slave, and then all of a sudden a gigantic uptick in traffic. And you can see there I've selected in Boundary that I'm only showing the ports that are related to MQ, and all the other ones are deselected. So having that granularity of view into how our MQ slaves are performing and getting the alert when there's a split brain, it lets us know immediately that we've got to correct this situation so that our application isn't kind of having a schizophrenic episode. And again, extremely helpful. We weren't really able to do this reliably before, and Boundary kind of came to the rescue. And so those are the only two, the two use cases I wanted to talk about today. With that, I'm going to hand it back to the Boundary guys to go from here.
Excellent. Thanks again for that. So really the last thing that we just wanted to touch on was, again, encourage people to hit our site. So if anybody wants to get signed up, they can get signed up. There's unlimited Boundary usage there. You can also get signed up for an AWS application optimization session. So no charge with that. Just reach out to us. We can get you guys going. Really appreciate that. And again, huge thanks to the Amazon folks for hosting us, and for Adam for coming in today.
Great. Well, this is Sherry, and I want to thank Miles and Dustin and Adam for your presentation today. And we've got a lot of questions queued up already, so let's take some time for Q&A. And Dustin, I'm going to point this first question back to you. Does Boundary work with AWS RDS, and if so, does it require an agent?
So today, with outside of EC2, so for services where we don't have access to root or we don't have access to shell, so like RDS, S3, ELBs, we can see traffic going to them and we can see traffic coming from them. However, we can't sit on the boxes, so we're going to have a limited perspective in terms of what we can report to people. But again, with the agent itself, we look at any of the traffic coming into or coming out of the NIC, so we'd at least be able to see it from your server or from your EC2 server's perspective.
Great, thank you. And Dustin, this is another question for you. Does Boundary have its own repository, or do you need to manually install and download and install is basically the question. Does that make sense? Yeah,
I think it makes sense. So yeah, we maintain our own repositories. I think, I don't know all the details that you're asking, but if you wanted to reach out, you can hit me at dustin@boundary.com, and I can provide a more detailed explanation. Great.
So another question for Boundary is, what kind of stacks can Boundary monitor?
So one of the great things about Boundary is it doesn't matter what stack someone has. So that question comes up all the time. Because we're looking at all the packet header traffic, because we're not doing anything specific to applications using hooks or anything else, we're immediately able to understand all the traffic. So it's stack agnostic. That's the easiest way to sum it up.
Great. Another question specifically to Boundary is there a difference from which network interface comes in and out?
No, that actually that's not going to matter for us. One of the things that you can do is if it matters to the end user, if a customer of ours wanted to specify a particular interface, they could do that. But by default, we automatically run discovery on it and we pick up all the traffic.
Okay, great. And there's a lot of technical questions here coming in, Dustin, so I'll just continue to kind of punt these back to you. But how does the meter agent affect the node when it's running on it? Is it overhead of running this agent?
Yeah, so the agent, it's going to introduce some level of overhead. Usually it's really only going to be at the CPU side. We've done testing in the past, and if someone were to install this onto like an EC2 large, by default, let's say it's an idle instance, they're going to see about 0.1 to 0.3% CPU overhead. However, that's obviously not real world. So real world is usually about 3 to 6% CPU for most application servers, but that's at a single core. So we're not, that's not 3 to 6% spread across the entirety of the box. It's on a single core. The other thing that's important about that too is, it does not affect the latency or application performance, which is, just another key thing.
Okay, great. I know we won't have time to cover all of these questions, but we really do appreciate folks asking these questions, and we will follow up with you offline as time prevails here. Dustin, another question for you is, can Boundary detect problems such as TCP, incast? How does that work?
Yeah, actually, that's something that's come up fairly commonly a couple of times. We have so we've seen that both with Amazon, and we've seen it with some of our customers on physical infrastructure. And yeah, absolutely, people have definitely been able to see that and spot that within Boundary. Yeah, that's a great question.
Okay, here's another question around kind of load level, I believe. It's what's the typical amount of data collected by agents on a server per day?
That would be dependent on the types of servers that it's being installed on. A general rule of thumb that we typically throw out is the amount of traffic that's being sent back to Boundary is generally going to be about 1% of total traffic that's monitored. So that's a rule of thumb. It can be more, it can be less. It's really going to depend on the application server. So one thing that we didn't talk about was pricing for Boundary. One of the great things, or one of the convenient things for pricing with Boundary is it's based off of the volume of traffic. So we don't care about the number of servers you have. If you have 2 servers or 20 servers processing the same amount of data, then it's all about just the number of, or rather the volume of traffic that's coming back to Boundary. And that traffic, it's generally 1% of total traffic being monitored.
Here's another relative question to the metric outliers, if you will. The question is, when looking at metric outliers, you can get lost in the average. Does Boundary allow us to see the percentiles, like a 95th percentile of TCP?
So we do provide percentages with some of the numbers. That person's right. I mean, averages can definitely, that can skew things. We're in the process of adding in a number of other options for that. So today we don't have anything around like 95th percentile or anything else, but we're definitely in the process of adding that in the product. We actually have some examples that we could show that person if they're interested in getting on the call and pursuing that further.
Great. And another question around sort of the agent is, and this might be a dependency question as well, but what's the overhead on the server where the agent is installed?
So I think that was the same question that came up earlier. So that just comes back to, general number is usually about 3 to 6% on a single core. So yeah, that's good.
And this is a question back to you, Dustin. I know we're bombarding you with questions, and we've got time for, I think, 2 more questions here. Does Boundary introduce sort of latency into the application transactions?
It doesn't. It doesn't. So that's the convenient part about when you install Boundary. We're not, there's no kind of hooks, there's no instrumentation. So the moment that it's dropped in, we're not going to add any interference with any of the apps that are out there. You drop it in, and it immediately just works without any overhead or interference.
Great. And one last question here. In terms of, is there any way to correlate the message traffic to what is going on with the server? Like, for example, low traffic might be interpreted as good, but could be happening because the server is compute overload and is not able to handle the request.
Yeah, so that's a great question. So one of the things that I called out before was the ability to be able to add those annotations into the UI. So with Boundary, we're going to show traffic, or traffic and the flow information as things are fluctuating. But then one of the killer things about Boundary is being able to hook in other tools to help people troubleshoot and diagnose exactly what's happening. So if you look at tools like Splunk, New Relic, AppDynamic, you can post their events into the Boundary UI so that people can figure out, like, okay, well, at the time that we saw this spike in traffic, we also suddenly received this notification from Splunk or this notification from any other service that's out there, so that then people can try to determine what the root cause is and what the impact of that event was.
Okay, great.
Actually, something just to add to that, I completely glossed over this during the presentation, but anything that people can do within the UI is accessible through our APIs too. So we have public RESTful APIs, so if anybody wanted to tie in any other services, or if someone wanted to pull information out of Boundary, that's absolutely an option as well.
Great, thank you. And this is a question maybe for Miles or for you, Dustin, but can we monitor AWS RDS with Boundary?
Yeah, so with RDS, I think this is the question that was asked earlier. We can monitor the traffic going to it and coming out of it, but we don't have an agent that can be installed on it. We'd love it if we could work with Amazon on trying to get our agents on those boxes, though. So we're all ears if Amazon wants to help us with that.
One additional detail there, RDS has just released a whole series of automatic metrics and alerts that you can set based on database activities. And you could certainly pump those alerted events into Boundary as annotations, so that if we're in the middle of a multi-AZ failover, you'd see that actually happened, and you'd see it annotated within Boundary.
Great, thanks, Miles. And Miles, this is an additional question for you, and this will be our last question today. But isn't a solution that uses multiple regions just much more expensive based on the internet, cost? Can you speak to that from an AWS perspective?
Sure. So AWS has built and designed this multi-regional footprint to give people a whole bunch of different advantages in terms of high durability and low latency to your customers. And Boundary, I think, does a great job of evaluating the traffic intra-AZ as well as across the regions. Pretty recently, it was we made a pretty big announcement that we're reducing prices. Amazon has a pretty consistent track record of doing that. But one of the sort of footnote items in that was a really significant price reduction in the region-to-region traffic costs. So today, like for example, out of our US East facility, where the traffic cost to go from US East to US West used to be the same price as full normal internet transit at, say, 12.5 cents a gigabyte. Now it's just 2 cents a gigabyte to send that traffic. So almost the same price at a penny a gigabyte as the traffic moving between your availability zones. So really significant cost advantage there. And hopefully Boundary will help us help people keep their eye on it.
Terrific. Well, that's a high note to close on. So I'd like to special thanks to our presenters today. Thank you, Dustin from Boundary and Adam from Okta.